Thanks everyone for coming to my talk today. And my name is June, and I'm going to present context-side model understanding and debugging via interpretable context, advised by Professor Enrico Bertini. And I also want to thank Professor Min-Soo Kwon for his support to this project. Let's first start with some hand drawing. Imagine that I just draw this something, and a model makes a guess of 90% of chance it can be a pear, or probably an onion, or 80% of chance it can be a potato or an avocado. But why did the model make such a guess? So we try to make some explanations, like it's really like it looks like a pear or probably an onion or a potato. So this is what we call example-based explanations. Actually, examples are widely used to explain model predictions. Researchers use prototypes and criticisms to show what the model has learned and not captured. Also, some researchers try to generate some counterfactual examples to demonstrate how an instance has to be minimally changed to significantly change its prediction. Sometimes people just try to see the nearest neighbors, try to check how the model makes predictions on similar instances. There are also other example-related explanations. In recent years, researchers also conducted user studies which prove that examples are really useful for model understandings, especially for laypersons. However, there's a lack of systematic investigation to answer the two questions. First, what factors are taken into consideration when using examples for model understanding and debugging? Second, how does examples help with model understanding and debugging practice? To answer these two questions, we firstly formally define the context of an instance as a set of examples selected or generated according to certain criteria in order to understand how the model makes a prediction on this instance. So the main contribution of this work include two things. Firstly, a literature review of existing methods that involves context, which derives a taxonomy of interpretable context. We also contribute a visual analytics system called context-side, which adapts the key elements from interpretable context to help with the specific task of model understanding and debugging. In the later part of my talk, we will go through the two main contributions. Firstly, the literature review. To understand what factors are actually taken into consideration when using context, we conducted our initial analysis of a collection of 20 papers involving the usage of context to understand and debug a machine learning model, which derives this. Interpretable context. Its taxonomy include context generation, which is what factors people usually take into consideration when generate context examples, and context summarization, which is the methods people usually use to summarize, interpret, and present the context examples. For context generation, the first factor is similarity. Similarity can be data-driven, which is the raw data values. Like for example here, the two images, they look similar in terms of the raw RGB values of the image data. The similarity can also be model-driven, which is what the model assumes similar. For example, it can be the features extracted from the loss layer of CNN. In this example, like the two images look similar. They are semantically similar in terms of the features learned by the CNN. Second, model output. The context can have the same prediction or different prediction, or whatever prediction as the original instances. And as for the source of the context, it can come from the existing data. It can also come from generated data. As for context summarization, We can present it as just the instance level details, or we show the aggregated data distribution, or we can show some automatic generated summaries about the context content. Okay, now that we have the interpretable context, how does it help with a specific task? For example, model debugging. Here comes to our second part, prototyping. We want to design a prototype to support a specific task based on the context. The first thing we want to do is to generate some design goals for model debugging. In terms of context generation, we have two design goals related to the parameter customizations about the context generation. And for context summarization, we want to visualize the selected instance and its context so that users can visually capture the pattern of the context. We also want to provide auto-generated summary to guide users to interpret the context. Here is an overview of the user interface. In the later part, I will go through the user interface using an example of loan application data. Here we train a classification model which predicts whether a loan applicant will default or not in the future. This model has an accuracy of around 72%. So to debug the model, firstly, we select an instance predicted as default, but should be not default on the top of the view. By default, the context usually automatically generated, but we can adjust some parameters for generation by clicking the icon at the bottom of the view. Once the context is generated, the main view of the system is the feature distribution view, which is a visualization in the parallel coordinate style. The bottoms below it control what to be shown in the parallel coordinates. Specifically, in this view, each feature is represented by 3 axes. So in the first axis, the feature value in the original, it shows the feature value in the original instance and the feature value in the counterfactuals. In this specific example, this loan applicant have a feature percent trees with balance equals to 80, but to flip the prediction from will default into will not default, it should change the feature value from 80 to 35. So it seems like the model learned a too low threshold here for percent trees with balance for application with will not default. And the other 2 axes show the context examples with the predicted clause and those with the desired clause. Here we see that the context of this arrow instance seems to have more default cases around 80, but less not default. So this kind of imbalanced distribution of the context may be relevant to why the error happens. Further, the users can, like the system provided some auto-generated summary, which can be used to guide users to check what feature ranges should be looked at to reason about the errors. So here's the case. In general, in summary, we contribute a taxonomy of interpretable context, including context generation and context summarization. We also design and implement context site, a prototype of using interpretable context to understand and debug classification models. For the next step, because it remains unknown how practitioners use context to understand and debug a model in practice, so we plan to conduct an observational study based on context site. Specifically, we want to use context site as a probe to understand the following research questions. First, how do context examples and summaries help reach the goal of model understanding and debugging? Second, what role does interaction play when using context? Do practitioners have different workflow of using context? We can further discuss this in the later panel discussion part. Thanks for listening. I can take questions now.
Yeah, hi. I have a question about there's a taxonomy of these kind of context methods, but is there ambiguity about which one to pick? Like are there rules of thumb about what kind of context to use for different applications? Like what's the insight as to if I have a given model that I'm building, like, is it entirely just human and intuition driven, or are there some kind of like taxonometric rules of thumb or guidance that can help me pick the context type that's most appropriate in your whole taxonomy?
So do you mean methodology of deriving the taxonomy?
Well, I guess what I'm asking for is, it seems like if I have different models that I'm trying to build, like let's say one model might be, I'm improving the accuracy of my recognition for my self-driving car. Another might be I'm building a fraud detection model for my insurance company. They're very different. The kinds of context examples that I want to look at are quite different. Maybe their failure modes are different. There could be this taxonomy, but how do I navigate it as a user? If I look at the taxonomy, I stroke my chin and I appreciate it, what node do I go to when I'm actually debugging my particular application?
I see. That's a good question. So it's also relevant to our next step, I would say. So let's go back to the taxonomy itself. Originally, we generate this based on the 20 papers, and all the papers, they are used to debug a model and diagnose the model. And with for example, law amplification or many other different data types, tasks. So I would say that's like, if we want to derive the guideline of what insights can be derived from different context information, that should be done in our later observational study. That's the goal. Like if we go back to the research questions, the first one is, how do context examples and summaries help reach the goal? So in our plan, it's like we are going to observe how the practitioners actually use the system to debug a model, and trying to ask them to follow a think aloud protocol and say what insights they actually derived from each step of context generation, context summarization, and whether it's helpful for their ultimate goal of the model debugging. Yeah, okay. That's for the next step, and it's highly relevant. Yeah.
Thank you.
Hey, great talk. I'm really curious about your future work here. How would you define model debugging? What does that actually mean? Does that mean fixing the data? Does that mean training a new model? Does that mean new labeled examples? I'm just kind of curious, what type of debugging do you envision you could use a system like this for?
So model debugging, yeah, it's a good question. Thank you. Thanks for asking. It's actually, yeah, model debugging is a broad concept. I remember I read a paper from Google research. They actually defined the model bugs into 3 different types. One is a data level bug. Say originally the labels are wrong. And there are another type of bug that is related to the model. Say the initial parameters are wrong, like they stated wrongly, or they are also the 3rd type of bug that is maybe out of distribution. So there's a data shift from the training data to the testing data. So that's also what we want to see, like how context can actually help with different types of bug. Because in the paper I just mentioned, that paper, they actually conducted user study with feature importance. And they found that feature importance are useful for just one specific kind of bug. And we assume context is similar. It may also be useful for a specific kind of bug. Thanks.